Have you ever been taken down by a single mosquito? One minute you're enjoying a lovely summer evening, and the next you're swatting at your ankles, totally defeated by a creature a million times smaller than you. It's pretty amazing, isn't it? The smallest things can often have the biggest impact. Just think about a single grain of sand in your eye suddenly. Your whole day is about that grain of sand. Or, consider a single chili flake in a pot of soup. It can transform the entire meal from bland to blazing. It's a fundamental rule of the universe: size isn't everything. In fact, sometimes the smaller you are, the more power you can wield in very specific, very clever ways. This idea of tiny but mighty isn't just for bugs and spices. It's a huge deal in science. Scientists are always looking for ways to solve big problems using incredibly small tools. Imagine trying to fix a delicate wristwatch with a giant sledgehammer. It wouldn't work very well, would it? You'd just smash the entire thing to bits. You need tiny screwdrivers and delicate tweezers to get the job done right. Well, the human body is a lot like that wristwatch, only, infinitely more complex. When something goes wrong inside our cells, we can't just send in a giant wrecking ball of medicine. We need something small, precise, and smart. And that, my friends, is where our story begins. Alright, let's break down multiple sclerosis, or MS. Picture your body as a high-tech building filled with miles of electrical wiring. Your nerves are those wires carrying important messages from your brain to every part of you. And just like real wires, they need insulation to keep the signals running smoothly. That insulation is called myelin. It's like a protective coating around each nerve. Now your immune system is like a maintenance crew, always on the lookout for problems. Usually, they fix real issues like viruses or bacteria sneaking in. Most of the time, this crew keeps everything running perfectly. But in MS, the maintenance crew gets a little mixed up. They start removing the insulation from the wires, thinking they're fixing a problem. It's like accidentally pulling off the coating from your phone charger and wondering why it sparks. This case of mistaken identity has serious consequences for your nerves. The nerves that get attacked are part of your nervous system. Your nerves are like the electrical wiring in a house. They carry messages from your brain to the rest of your body, telling your legs to walk, your hands to clap, your eyes to blink. To protect these important wires, they're coated in a special insulation called the myelin sheath. In MS, the confused immune system, our rogue maintenance crew, starts attacking and damaging this myelin. When the insulation gets stripped away, the electrical signals can't travel properly. They might slow down. So, how do we solve a problem like a confused immune system? We need something that can sneak past the maintenance crew, get into the building, and deliver a very specific message. Enter our heroes, nanoparticles. Now, when you hear the word nanoparticle, you might picture a sci-fi tiny robot, maybe with laser eyes. But reality is even more amazing. A nanoparticle is an incredibly small particle. Nano comes from a Greek word meaning dwarf, about 1 to 100 nanometers in size. A single human hair is about 80,000 nanometers wide. You could fit thousands of nanoparticles on the tip of a pin. Think of them as the postal service of the microscopic world. Tiny customizable delivery trucks, designed for a specific size, designed in different shapes, and given a special address label on the outside. That label helps them navigate the bloodstream and hit only the right cells. Like a pizza delivery drone flying through a crowded city, avoiding the wrong buildings and landing perfectly on your balcony with a hot pepperoni pizza. Now for the really cool part, this isn't just a wild idea on a whiteboard. Scientists have actually been testing this. In experiments with mice that have an MS-like disease, this nanoparticle therapy has shown incredible results. They injected these mice with the myelin-filled nanoparticles. And guess what happened? The rogue immune systems in the mice calmed down. The attacks on the myelin stopped. Some of the mice that were already having trouble moving actually started to get better. The nanoparticles successfully retrained the maintenance crew. The mice were able to walk again, all because these tiny Trojan horses delivered their message of peace. This is a huge deal. Stopping the attack is the first and most important step for a disease like MS. If you can prevent the immune system from causing more damage to the nerve's insulation, you can halt the progression of the disease. Now, if you're finding this story of microscopic heroes as cool as I do, make sure you hit that subscribe button or give this a big thumbs up. Seriously, every click helps us bring more awesome science stories to you. Alright, so we have our tiny delivery trucks, the nanoparticles, and we have our mission to retrain the immune system. How do we actually do it? This is where the plan gets really clever. It's like a modern day Trojan Horse story. Hiding soldiers to attack a city versus hiding a peace treaty to stop an attack. Scientists load the nanoparticles with tiny fragments of myelin, the very substance the immune system is mistakenly attacking. It sounds a little crazy, right? Why would we inject the very thing that's causing the problem? Like showing a picture of your ex to a jealous bulldog. But here's the trick. Nanoparticles are designed to look like harmless debris, tiny fragments of a dying cell the body cleans up. The immune system has special janitor cells that gobble up debris. Janitors gobble up our nanoparticles. They break them open and find the myelin fragments inside. Because the particle looked like harmless trash, the immune cell doesn't sound the alarm. So, are nanoparticles the secret to curing MS? It's still too early to shout eureka from the rooftops. The incredible results we've seen have been in lab studies and animal models. The next giant leap is testing this technology in humans to make sure it's both safe and effective. Human trials are the ultimate test for any new medical breakthrough. They take time, care, and a lot of smart people. But the promise is undeniable. This nanoparticle approach represents a massive shift in how we treat autoimmune diseases like MS. We're moving from a sledgehammer approach to a scalpel. The potential here is enormous. If we can retrain the immune system for MS safely, what's next? This Trojan Horse nanoparticle tech could be adapted for other autoimmune diseases. Type 1 diabetes, immune attack on insulin-producing pancreatic cells. Rheumatoid arthritis, immune attack on the joints. Each disease needs custom-designed nanoparticles carrying a different peace treaty. The underlying principle inducing tolerance could change millions of lives. Next time you feel defeated by something tiny like that mosquito, think about nanoparticles. The smallest things can carry the biggest hope.